Welcome to M&E. We have a very interesting question today. We are asked to calculate the area of the cycle. That is, this cycle here. We have the length of this line segment to be 6√3 kilometers. This line BD is 9 kilometers. And this segment DE is 3 kilometers. We can see this angle is a right angle. And this angle has its size to be x. So how can we solve this? How can we calculate the area of the cycle? Well, it is very simple. I'll start from this triangle. We can see it is a right angle triangle. We have this side divided into this segment, this and this, which have their length to be 6√3 kilometers, 9 kilometers, and 3 kilometers. So therefore, the total length of the line is 6√3 kilometers plus 9 kilometers plus 3 kilometers. 3 kilometers plus 9 kilometers is 12 kilometers. So it is 6√3 kilometers plus 12 kilometers. Now if we assume the length of this side to be x and this to be y, we can use the Pythagorean theorem. The Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this here. So by Pythagoras, the square of this 6√3 kilometers plus 12 kilometers is equal to the sum of the squares of this x and this y. So 6√3 kilometers plus 12 kilometers all squared equal to x squared plus y squared. From 6√3 kilometers plus 12 kilometers, since 12 is 6 times 2, we can factor out 6. So it is 6 into bracket √3 kilometers plus 2 kilometers. Let's take out the unit. 6 into bracket √3 plus 2 all squared is 6 squared times √3 plus 2 all squared. 6 squared is 6 times 6, which is 36. And √3 plus 2 all squared is √3 plus 2 times √3 plus 2, which is √3 times √3 plus 2 times √3 plus 2. √3 times √3 plus 2 is 3 plus 2 √3. And 2 times √3 plus 2 is 2 √3 plus 4. 2 √3 plus 2 √3 is 4 √3. So it is 3 plus 4 √3 plus 4. So now 36 into bracket 3 plus 4 √3 plus 4 equal to x squared plus y squared. What are the values of x and y? We don't know, but x is the length of this side and y is that of this side AF. And if you look, both are tangent to the cycle at this point and this point. From cycle theory, there is a rule that the angle between a tangent and its radius through point of contact is a right angle. That is, if we come here, draw out the radius of the cycle to this point and this point of contact, the angles formed are right angle. So this angle and this angle are right angles. We let radius be r in length. Now look at this quadrilateral. Since this angle, this and this are right angles, the fourth angle will also be a right angle because the summation of angles in a quadrilateral is 360 degrees, and 360 degrees minus 90 degrees minus 90 degrees minus 90 degrees is 90. Now since all the angles of the quadrilateral are right angles, and we have this side to be perpendicular and equal to this side, the quadrilateral is a square-shaped quadrilateral. We know all the sides of a square-shaped quadrilateral are equal in length. That is, this side and this side are equal with these. So since the length is r, this must also be r. Now we assume the length of the leftover segments, this be a and this b. Now look at like its whole length is x, but it is divided into this r and this a. So x equal to r plus a, while this y is the sum of this r and this b. So y equal to r plus b. Substitute it here. Now 36 into bracket 7 plus 4 root 3 equal to r plus a all squared plus r plus b all squared. Now look at this line BE. It passes through two distinct points on the cycle and ends at an external point. That is, it is a secant. We know it intersects this line, which is a tangent at this point. From the cycle theory, there is a rule that if a secant and a tangent of a cycle meet at an external point, the product of the length of the secant and its external segment equal the square of the length of the tangent segment. That is, the length of this, which is the sum of this 9 kilometers and this 3 kilometers, multiplied by this 3, which is the length of the external segment, equals the square of this a. So 9 plus 3 times 3 equal to a squared. 9 plus 3 is 12. 12 times 3 is 36. So 36 equal to a squared. Take the square root of both sides. Here square root of a squared is a, while here square root of 36 is 6. So a equal to 6. Substitute it here. R plus 6 all squared is r plus 6 times r plus 6, which is r times r plus 6 times r plus 6. R times r plus 6 is r squared plus 6r, and 6 times r plus 6 is 6r times 36. 6r plus 6r is 12r, so it is r squared plus 12r plus 36. Now 36 into bracket 7 plus 4 root 3 equal to r squared plus 12r plus 36 plus r plus b all squared. Let's go to segment B. This line AD is a secant and it intersects this tangent by the tangent-secant theorem. Since this is line AD and this segment is its external segment and this is the tangent segment, 6 root 3 plus 9 times 6 root 3 equal to b squared. 6 root 3 plus 9 times 6 root 3 is 6 root 3 times 6 root 3 plus 9 times 6 root 3. 6 root 3 times 6 root 3 is 36 times 3, which is 108. And 9 times 6 root 3 is 54 root 3. So 108 plus 54 root 3 equal to b squared. Take a duplicate of the equation. 108 is the same as 12 times 9. And 54 is 6 times 9. From 12 times 9 plus 6 times 9 root 3, 9 is common. We factor it out. So it is 9 into bracket 12 plus 6 root 3. Take the square root of both sides. Here square root of b squared is b, while here square root of 9 into bracket 12 plus 6 root 3 is 3 times square root of 12 plus 6 root 3. Now what is square root of 12 plus 6 root 3? 12 is 9 plus 3, and 6 root 3 is same as 3 root 3 plus 3 root 3. We bring 3 root 3 close to 9 and 3 to the back. Now it is 9 plus 3 root 3 plus 3 root 3 plus 3. From 9 plus 3 root 3, we can factor out 3. So it is 3 into bracket 3 plus root 3. While here, this 3 is the same as root 3 times root 3. From 3 root 3 plus root 3 times root 3, we can factor out root 3. So it is root 3 into bracket 3 plus root 3. From 3 into bracket 3 plus root 3 plus root 3 into bracket 3 plus root 3. 3 plus root 3 is common. We factor it out. So it is 3 plus root 3 times 3 plus root 3, which is 3 plus root 3 all squared. And square root of 3 plus root 3 all squared is 3 plus root 3. 3 times 3 plus root 3 is 9 plus 3 root 3. So b equal to 9 plus 3 root 3. And we have here b squared equal to 108 plus 54 root 3. Here, r plus p all squared, if you expand, it's r squared plus 2rp plus p squared. These values here, we substitute them here. So it is r squared plus 2r into bracket 9 plus 3 root 3 plus 108 plus 54 root 3. 2r into bracket 9 plus 3 root 3 is 18r plus 6 root 3r. This r squared plus this r squared is 2r squared. 12r plus 18r is 30r. 36 plus 108 is 144. From 2r squared plus 30r plus 6 root 3r plus 144 plus 54 root 3, we can factor out 2. So it is 2 into bracket r squared plus 15r plus 3 root 3r plus 72 plus 27 root 3. This 36 divided by this 2 is 18. 18 into bracket 7 plus 4 root 3 is 126 plus 72 root 3. Take it to the left. Here 72 minus 126 is minus 54. And 27 root 3 minus 72 root 3 is minus 45 root 3. So r squared plus 15r plus 3 root 3r minus 54 minus 45 root 3 equal to 0. This is a quadratic equation. If you use a quadratic equation formula to solve, you'd get r equal to 3 root 3. That is, the radius of this cycle is 3 root 3 kilometers. Formula for calculating the area of a cycle is by r squared. R is 3 root 3. 3 root 3 all squared is 9 times 3, which is 27. So area of cycle equal to 27 pi kilometers squared. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.